go through to do today. As you can see, today we only have one sheet of the lecture slides. So I'll just quickly go through what we haven't finished from last time. And also there was one part that we were kind of confused last time from the second normal form. So I'll clarify that today. And after that, we'll actually do a quiz today. We haven't done it for a while. You might miss it, or I don't know. It's gonna be really easy. And I'll just give you a, It won't be the stuff on the slides today, but it's really easy. But if I tell you, I feel like you're gonna be distracted. No one's gonna listen to me. But anyway, it's gonna be Armstrong exams. Alright. And after that, I'll return the graded midterm for you. And we will go through the questions and discuss. So if you find any pause after I return it, that you think you get it right, but we didn't give you the points, then you can come up to me and then we can discuss about that. After that, I told you guys I was going to give you back the project, the graded project phase 1, but the TA needs a bit more time to wrap up because we are going to give you feedback. She is actually writing feedback for you. So other than giving it today, she will post the grades. So you can see the grades for your phase 1 today on Angel. But we might wait till Wednesday to get the feedback back. So yeah, sorry about that, but you can already start working on phase 2 based on what you have learned. Okay, all right, so I should actually go to, let's quickly talk about something we got stopped last time, which is here. All right, so in the last lecture, ooh, that looks really big. Give me one. No? No. Okay, let's look at here. Maybe a bit tiny. I'll fix that later. But last time we were talking about this one, and remember we were having a tiny debate on whether this is second normal form, right? And the answer is yes. Why is that? John, you can figure it out, right? Came to me and told me about it. Yeah. So let's take a look at the definition. Sorry about this, but here is full, as you remember, here's partial. So we say a relation R is in second normal form if every non-key attribute in R is fully functionally dependent on the candidate key of R. Right? And remember what the full functional dependency means? It's just right here. Okay? If removing attribute A from X makes X determines Y not hold. So then we went to look at this example. So ignore these red lines. The only one underlined is SSN. All right? And then we figured this is second normal form. Why is that? Some people are arguing, but D name and D manager are determined by D number. However, is D number alone a candidate key? No, right? Because if this will happen, it's either we also have this underline, right? Oh yeah, that's or they together determine that. Okay? So that last time we were a bit confused with this one, so I hope you can understand why this is second normal form. So let's move on to, not this. Let's move on to today. Hope this will work. So today I'm just going to finish up on third normal form. Alright, on third normal form from last time. So last time we went through the definition for third normal form. We say a relation R with functional dependencies F is in third normal form if for all the X determines A in, what does F plus mean? Closure, yeah. In the closure, satisfy one of these So the first one we say is trivial because if A belongs to X, then certainly. Then the second one is X contains a key for R, which means X is a super key. Or the third one will be A is part of some key for R. And we also said in your project, you are expected to transform your schema to third normal form. Okay. And after that, let's take a look at 2 examples that we can see whether it's third normal form. The first one is this one. Actually, I already have the answer down there. But if you look at it, is this the third normal form? Like following the rules. We can see, for example, on the functional dependencies, you can see SID determines card, and then card also determines SID. So if you take a look at the rules on your slide, then what is the first one based on which rule? So if we say here is the X, right? And here is the A. Then SID determines card should be because of which one? Do you think it will be the first one? That's the least likely one, right? Because card is not part of SID at all. How about the second one? X contains the key for R, which is saying SID contains the key for R. So it's true. Yes, right? Because SID is the primary key. Right? So this one is because of this. Okay? How about this one? Card determines SID. Will be the first reason? Also not. How about the second one? Does card contain the key? No. How about the third one? Is card part of some key for R? Yeah. Okay, so if you work through this, then you can see this is third normal form. Let's take a look at the next one. This one. Okay. So if you take a look at this one, in the last time the slides I printed out, it was wrong, but I fixed it this time. So it should be correct one on your side. So this one, well, if we're going to decompose it, we know it's not third normal form. So what would you do to make it third normal form? Yeah, only one sheet. Just anyone? Or maybe let's not think about it in the way that's the normal form. Just by looking at it, by observing it, in terms of designing it, do you think there's one part that seems not necessary to make the whole table together into one? Or can we say, let's find out which part of it is stopping it to be the normal form. So here we have 2 functional dependencies, right? The first one is SSN determines the rest of them. I just won't write it down, right? And the second one will be the department number determines the name and the manager. So if we look at the first one, do you think it follows one of the rules in the normal form? Number 2? Number 2? Yeah, number 2. Why is that? It's because SSN is a key. Okay, so that follows the second one. How this one. D number determines D name, D manager. Do you think it follows any of the rule? No, right? Because even if you look at the second one, it's not going to be the first one for sure. If you look at the second one, this is not a key, right? We didn't underline that. And it's not going to be the third one either. Correct? So, what would you do to decompose it and make it the normal? Or just by looking at this. SSN determines D number.
determines D name. Just SSN determines D name.
Bless you. So you're saying make it all the way there. Do you think that would be better? Make it, in terms of designing it, make it more efficient? Or you can just simply break it down. Okay? The whole time I was trying to hint you guys. Maybe I did a bad job. But this is what we can do. Alright? So now if we decompose it and you look at each of them, do you think both of them are in third normal form? No, they are, right? That's that. I'll give you some time to write it down. And as I said, we are having a quiz today. Do you guys want me to review, like, for a few seconds? Okay. All right, everyone got that? All right. Okay. So what I'm gonna test on in the quiz is gonna be one thing. All right. So what I will be testing on will be Armstrong axiom. If you can remember what it is. So reflexivity is just basically saying, when we talked about x determines y, if y is a subset of x, then x determines y. All right? And this is the most trivial one. Then the second one is augmentation. We said it has a taste of multiplication, right? Because if you look at if x determines y, then we'll put a z on both sides, and it still is true, okay, for any z. But not the other way around. Remember, we said we cannot cancel z. And the third one is transitivity, which I think is a very intuitive one, right? If we have x determines y and y determines z, then x determines z. So remember that example we worked through? This one. Remember this one? Where you are given a schema and I give you 3 of the functional dependencies. We say these are given, right? And later on, based on these 3, we can actually derive more functional dependencies. Right? So in here, all right, let's just take a look. So if I give you these 2, what can you do with it? If I say through transitivity, then JP. Okay. And what if I do augmentation? So if it becomes this, then it is because augmentation. Okay? How about this? What does this make you want to do? Yeah?
Quick question. Is
Yeah.
there a reason that you chose to do J?
Oh, that is because then we have a JP here and we want to do transitivity. Yeah, that's just for example. So here, if we have those two, then we want to do transitivity. And then that gives you the rest. Okay? So then we take a look at here. We were talking about, can we do this? No. Okay. That's it. It's gonna be easy as always. All right. So everyone got their midterm? You are? Oh, okay. 유자치. Oh, Brian. Okay. So we'll just quickly go through most of the questions. I think some of them I don't really need to talk about them. So yeah, what I will do is I will show you the grades for each section, and then we talk about that section. So let's look at the overall grade now first. The distribution is like this. All right, it's really good. So most people got, let me make it bigger. So most people, yeah, tons of people got above 90, and our median is actually 92, really high. And our mean is, average is 87. So if you are, let me see. So if your total grade is below 70, please contact me and we can talk about it so we can see how we can figure it out to help you out. And for 100, as I said, we have 5 people that got 100, and a lot of people are just like 1 point off from 100, 1 point away. And the section that you guys did the best is section first. So most people got full points. All right. Yeah, half of the class got full points for the first section. So let's just quickly look through. I think when grading, we're not really strict either, and those answers are just really simple and straightforward. So for example, let's look at here. The first question we'll know, for each attribute of a relation, there is a set of permitted values called the domain of the attribute, okay? And this second question for true or false, first one, there could be more than one primary key. When you see here, you should already put down false, okay? And the second one is the relational data model is the most widely used data model today, true or false? True. And then the third one, the data model is a collection of high-level constructs for describing stored data that hides low-level storage details. That's also true. Just make it really complicated, but it's true. And this one, which schema in the levels of abstraction allows data access to be customized at the level of individual users or groups of users in some information in view are not stored explicitly, computed as needed. That is external. Okay. And this one, really simple, we all work through it in our quiz, right? So you just want to answer whether it's logical data independence or physical data independence. The first one, the ability to change the logical schema without having to change the external schema is logical or physical? Logical. The second one is using new storage devices, physical. The third one is changing the index from hash to B-tree, physical. The fourth one is adding new entities, logical. And the last one, using different file organizations or storage structures. Okay. And this one, we got a couple of different answers, but this one is which kind of data model? Hierarchy. Okay. In this one, the sixth question in section 1, we ask you the atomicity in ASIC property, what does it mean? This should be pretty straightforward, right? You just explain. We aren't really looking for a specific answer, so as long as you describe it well, we give you the points. And these two actually got most of the points deducted from here. So the seventh question is, which two operators we learned in relational algebra are unary? So unary is kind of, you can say, contrary to binary. Okay? So unary, which two are they? Selection and projection. And some people didn't write down the symbols, we also took out some points from that. So selection we use sigma, projection we use pi. Okay, so you want to write those two down, and each of those things is 1 point. And for eighth question, which three operators we learned in relational algebra require the involved relations to be union compatible? What do we mean by union compatible?
Same schema.
Same schema. Then what are the three operators that require them to be union compatible? Union, intersection, and set difference. Okay, so a lot of people write down join. Does join have to be union compatible? No, right? Also, a lot of people also write down cross product. And that's the one that we put emphasis on. This one does not have to be union compatible because when you take two tables taking a cross product, the end result of the schema, just the two schema concatenate together. Okay? So they don't have to have the same schema. So that's it for problem 1. You guys did really well for that one. And the second one was also pretty good. This is for problem 2. So for problem 2, also, almost half of the class got full points on that one. And the average for this section is 23.9. And median is 25, which is one point off. Okay. I kind of forgot which point most people lose, but you guys did really well in this one. Let's see what this one is about. So this here, we are just drawing entity relationship model. So most people lose points because of the first two, actually. But some people write down some that are really different from the answer I was looking for. And it might, if you think your answer actually makes sense, but I take out points, you can come and discuss with me. Okay? So for the first one, we said professors can teach the same course in several semesters, and each offering must be recorded. Then we mean, here I just say professors, right? Teaches courses. So by adding what can we fulfill the requirement where each offering must be recorded? Yeah. We should add an entity here. You can put a semester or whatever. Alright? So a lot of people right here only use an attribute. Then remember we say then that multiple semester cannot be recorded. Correct? Because then it's identified by professor and course. How about the second one? Transform from here. We said professors can teach the same course in several semesters and only the most recent offering needs to be recorded. And how do we change from here? Yeah, we just change here into attribute. Right. Okay, then let's take a look at number 3. I think most people got number 3 right. So we're saying every professor teaches exactly one course. So if we change it based on that one, exactly one means we should change here, right? Into what?
Thick arrow.
Thick arrow. Yeah. And then we say in every course must be taught by some professors. Remember I said it's like multiple. I didn't put the S. So we should change here into thick line because it's saying at least one, not at most one. Okay, so some people kind of get it confused between thick line and arrow. So that's for the third question here. Really easy. And the way we took out points, basically if you made it one mistake, then it's 1 point off, 1 point off. Okay, if I took off too many, tell me. And here is the one that actually allow many different kinds of answers, because some parts, the more I look at it, the interpretation have multiple ones. All can be valid. Right? So I don't think I'll draw all of them down. We can just talk through the requirements. So for the first one, we say people working in the fashion industry can be designers or buyers. And the whole thing, I'm kind of following a really similar example as the movie one we worked through in class, right? So what does the first requirement tell you? Is that right? We are doing the hierarchy. So if you didn't do the hierarchy, then that's wrong. Okay, and how do we denote hierarchy? Is and with a triangle. So some people use diamond for that. Yeah, I took off points from that as well. So just remember, the first one we can put people, or you can say fashion industry, I don't mind. You can say people and then ISA, and then you put designers, buyers, as the child entities. Then the second one, the designers sign contracts with brands, and the designer can have multiple contracts with the same brand at the time period. So for this one, this is where people get a lot of different kind of interpretation. So these together with the third one. When I was designing it, I was actually thinking you just simply have designers work for a brand, and then at that working relationship associated with the contract entity, and the contract entity have time attributes. But some people will interpret that into different ones, like designers will sign a contract, okay? Or they will have, and then separately, designer works for a brand. So both are fine, I don't really mind. So either way, I'll give a point. If I take off, let me know as well. And the third one is a brand can only have one designer at a time. A designer can also have only one, the designer can also only work for a brand at a time. So here is a lot of, people have a lot of different interpretations as well. When I was thinking about it, I was thinking about at most one, okay? So a brand can only have at most one designer at a time, but if you interpret it into exactly one, that's cool with me. Okay, so for the third one, either at most one or exactly one, you'll be right. Okay. And for the fourth one, we have designer design clothes. If a designer leaves the industry, the clothes he designed will be removed from the fashion industry. So most people got this right. What does this hint you? What kind of component? Weak entity, right? So this is weak entity. So a lot of people, when denoting weak entity, you lose a couple of points because maybe you didn't put the weak entity with thick line, or you didn't put the relationship associating with weak entity with thick line, or even the edge between them, you didn't put thick line. Okay, so for here, I make it really flexible. If you only put thick line between the weak entity and the relationship associated with, that's fine. And I was looking for thick arrow. Okay, but either way, it's all right with me. In the fifth requirement, we have buyers work for retailers. A buyer can work for at most one retailer, while a retailer has to have at least one buyer. So for here, I think you guys should have no problem. Just don't confuse with thick line. With at most one, which is arrow, and thick line, which is at least one. Okay, so some people get it the other way around, and that will lose points for that. And the sixth one is actually easiest. The buyers buy clothes designed by the designer. So you just simply have buyers having a relationship with a weak entity. Clothes. Okay, so this one is really easy. But some people lose some points just because of some little mistakes. Okay, then this one. Let's look at how you guys. Okay, this one's doing really good. So most people got like 22, 25, 24. Median for this will be 22 points, and average for this section is 21.67. So I think I got all of the examples from lecture or the review session. All right, all of these are from review session. So if you look at this, you should be able to fill out the blanks. And here is the really simple one: create table students, right? And the primary key should be SID. So this is because we underline the SID. So this is really simple. And the second one, so some people got question in the exam asking me, what is this referring to? So this is actually referring to both of these, right? Because it's weak entity. So weak entity and the relationship associating with it together will be in one table, okay? So what will be the primary key in order to refer to the weak entity? P name and SSN, because it's partial key plus identifying owner's primary key. And how about here, foreign key? A lot of people just put employees SSN, and that's not what I was looking for, right? Because we said before, if it's a primary key of that one, it's optional. But what we're actually looking for is on delete cascade, right? Because if the employees is gone, the associating weak entities will be gone. Okay, and that's what we learned when we were learning about weak entities, right? And then let's move on to this one. I think most people will miss here, right? So because we use, for this one, exact one constraint, we can actually just put the manager's relationship with department, merge them together, correct? But when we do that, we have to be careful. The SSN cannot be null, right? So here is where we will put not null, okay? And what will the primary key for that be? Still the ID, that's right here. And the foreign key, what should you put right here? SSN references, which one? Employee, okay? And on delete, no action. That's because here we have exactly one, so we don't allow deletion. Okay. And this one should have no problem, I guess. Let me see. So, as I said before, these schemas are the one designing these tables, okay? So let's just take a look at each of them. So the first one, we say delete tuple from employees where EID equals to 99999. Do we have 9999 in here? Yeah. So nothing will be deleted, and you should also say because there's no 9999. Okay. If you don't say it, just nothing will happen. Then you can say that for everything, right? Okay. So the second one, if we add a tuple with EID 1, 2, 3, 4, 5, DID 4, and since 2015 to the works in table, is it valid? No. Why is that? There's no DID equals to 4. Okay. Okay. How about the third one? We want to add a tuple of 20045 where the name is Laurie, age is 26, salary is 10,000 to the employees table. Can we do that? That is because David already has the same EID. Okay? This one is also really simple. All right. So let's move on to the last one. The last one is the most kind of tragic one in some sense. So I saw a lot of really interesting answer. So a lot of people didn't do this part well, either because some people actually have no clue of the relational algebra, so you were kind of making operators on the spot. So I was trying to understand your operators, and I still couldn't. So if you still wrote something down, even though it seems like another language, I'll give you 1 point for that. Because I think you tried. But yeah, otherwise, most people did really well in this section because actually didn't make it too complicated, right? So some people will lose points on really small things. So your big idea is right, but when you're, for example, when you're joining tables, you just directly use natural join. but maybe you should specify some condition. Okay, I'll talk about which one it is. So let's take a look. The first one, we say find the names of sellers who have reserved both 1 or 4. And this is really simple, right? This is almost like the first query that we learned. So you just need to first do a selection on both, correct? And what after that? You want to join with sailors? Yeah, join with sailors and do a projection to get the names, correct? So we want the names. So the first one, most people got it completely right. Second one though, we want to find the names of sellers who have reserved, we want to find the SIDs of sellers who have reserved a green and a blue boat. So a lot of people, when doing selection, they just directly say the color equal to blue and color equal to green, and then do it on the boats. So what would this give you? Nothing, right? Because there's no boat that will have color both at the same time equal to green and blue. So what should you use for that? Intersection, okay? So that one I was testing on intersection. And for the third one, find the names of sellers who have reserved at least 2 boats. And here we have a lot of different kinds of answer. Some people will do aggregation first. Okay, you count it, and then you find the ones that are greater or equal to 2. And the other way is the way that we taught in class. There are 2 ways. The first one is to do a join between reserves. But a lot of people directly do natural join for a reserve. So they have reserve, I'll just put R. Doing natural join with reserves, what would this give you? Yeah, so it will still compare both SID and BID. So what should you do for here? Specify. Yeah, specify what you want to compare with SID instead. Alright? So if you don't have that, you lose 1 point for that. Okay, because it's actually a big deal. The result is completely different. Otherwise, you can do a cross product first. Okay? And for this one, I was also testing on you are supposed to do renaming. Okay? We are renaming the field into different names, so then we know which BIDs from which one. So if you didn't do renaming, then this point is left. You can't say later I'll just compare BID not equal to BID. Then I don't know which BID is from where. Okay, so that's for the third one. And the fourth one, reserve all boats. Some people really sneaky. You still do a count and you just say if the count equals to 4. Okay? I still give you a point because I think that's kind of smart. You kind of worked it around. But what do you think is really testing on for this one? Division. So you're supposed to use division. So a lot of people, when doing division on reserves and boats, if you directly write this, will this work? No, right? Because they have other fields, right? So in order to fit the format for division, what should you do? You should do projection, right? And here we are actually projecting SID and BID, and for both we only want BID, correct? So you need to get to here to get it all correct. All right, and the fifth one we are trying to find the average rating of sellers grouped by the colors of both they reserve. So,
can you project, like, division for the reserve? Do you have to project, like, does it have to have 2 columns, or can you have the bottom?
2, because you have to specify. If you don't specify, for this, it's saying you want to find all the SIDs that.
Yeah, I know, but like for this question, but if you say that you want to find all the SIDs of the date, can you just leave all?
Oh, no, then later you join it back. Because following the division formula, it has to have 2 fields here and 1 field. Okay. So for the fifth one, what operator are we looking for? Also aggregation, we want to use alpha, right? In this one, you will take 2 arguments. The first one is the grouping, correct? Group by the color. Then the second one, you take the average. So that was the answer I was looking for. But some people get very smart. They do tons of lines. So the first one, I choose blue, and the second one, I choose red. Third one, I choose green. Okay? And then finally, you like union them all together. So that would be cool for me as well. But if you write that down, then the next question will be wrong because you don't have the color information. Okay? So that's for the fifth one when I'm looking for aggregation operators. Okay, last thing. So for drawing the result, what am I looking for? I'm looking for drawing a table that has 2 columns, 3 rows, correct? So I'm just basically, I want you to draw a table that has color, average rating, and then each color with average rating. And average rating, I don't require you to really compute it out. Because some people, maybe that's the last question, they got confused. A lot of people confuse the average rate. So that's all right for me. So yeah, if you have any question in terms of grading, you can come up here and we will fix that. And oh yeah, so don't toss away your cheat sheet for midterm 1. Are you guys keeping it? Because you can use it for final exam. Okay, so I was thinking, don't go home and then like tear it all up. Yeah, it's done. Alright, I'll see you guys on Wednesday. Yeah.